did lesson 24 in class today, and that was looking at situations where two constraints must be met simultaneously. And we've done it before with equations, now it's inequalities. So that creates a system of linear inequalities, and in order for it to be a solution, it has to satisfy both constraints. Really easy to see when it's the shading, because then it's just where the overlapping shaded area is. All right, so the only difference now from equations to inequalities is now when you see words like at least, no more than, at most, a maximum of, their budget is this, you know that it's not going to be an equal sign, it's going to be an inequality. So let's practice that. I do have an example ready. So this is great practice for your constructed response test, especially where you have to make the system from a situation. For example, on your practice test, when you look at the back, it says create a system of equations or inequalities. So you have to determine what's appropriate based on what is said. But to kind of give you a hint, our whole focus has been inequalities for this part of the unit. So please make a system of inequalities. When I say system, what's the minimum amount that I need? So system of linear inequalities, I need at least how many? You speak up. For it to be a system, I need at least 2. And at algebra 1-2 level, you're just going to do 2, but it can't be more. And it just has to use the same variables. So in this one, you'd like to see how many baseball and soccer games you can attend this spring. Travel time for baseball games is 2 hours and soccer games is 1 hour. You would like to spend no more than 15 hours traveling to the games. In total, you'd like to attend at least 8 games. And always when it's a word problem, I tell you to look for what first? The totals. So table 2, can you tell me one of the totals in this situation? John, Cohen, and Mason, tell me one of the totals in this situation. 15, good, that is a total. Because they want to spend no more than 15 hours total. I know it doesn't say total, but they want to spend no more than 15 hours combined traveling to the game. So to help you figure out what symbol you need to use, look at what's around that. If you want to spend no more than 15, can you spend greater than 15 hours then? So then put the sign. Okay, so then you can spend less than 15 hours if it's no more than. Can you spend exactly 15 hours? So then put it with the little line underneath. Then when you get to the part where you have to put what goes on the other side, it'll be easier now that you know what is contributing to the 15 hours, things like that. Table 3, what's the other total in this situation? 8. So you want to attend at least 8 games. So are you allowed to attend more than 8 games then? At least 8. Can it be more than? So then use the greater than symbol. Can it be exactly 8? So then use that line underneath it. Now, it didn't tell you what variables you need to use. Sometimes it does, and then you have to make sure you're following those instructions. But what is varying in each situation? Table 4, can you tell me that? What's varying in each situation? Okay. Class as a whole, what is varied, like, done? So you can use X and Y for your variables. What would X represent then? Okay, hours of what? Of the games. I'll elaborate on that. Spent doing what? So it's not about playing games, but it's traveling to, and then there's two different kinds of games. So we could make X be the baseball games. And then we can make Y be the hours spent traveling to soccer games. So you guys seeing like how to determine that? And that's what they're trying to figure out, is how many hours they can spend traveling to each. Wants to do no more than, or I guess it's games actually, when you think about it. Because if they want to attend at least 8 games, that would actually depend on how many games total. So in that case, I actually have to adjust these. It would be like number of baseball games. Because we do know the hours spent traveling to each one, so let me change that. So number of baseball games. And then the other one would be number of soccer games. So you would determine it and then keep it consistent. So number of soccer games. All right. So then now that we can determine that, what should go on the other side of the 15? Number 15 was the hours traveling. So table 4, what should go on the other side of the 15? Okay. Now, if X is number of baseball games and Y is number of soccer games, are we saying that they want to go to less than 15 games? Is that what this is representing? So then how can we change it to be talking about the travel time? Because it was no more than 15 hours traveling to the games. So what do I need to, what else do I need to put over here? 2x plus 1y. Because it takes 2 hours to get to any baseball games and 1 hour to get to any soccer games. I don't really need to put the 1 here, but you can if you want to. All right, but at least you picked up on the fact, I mentioned it earlier. Usually when you're making your system, usually one of the equations or inequalities is really simple. So table 6, what goes on this side of the 8? Remember that 8 is representing that they want to attend at least 8 games. So what should I write on this side? It is X plus Y. Because that would be number of baseball games plus number of soccer games combined. We need it to be at least 8. So yes. So now that's your system. That would give you the points for the first part of your constructed response, is making the correct system. using the correct sign and distinguishing what your variables are. If you don't tell me what the variables mean, or if you're very vague, then you won't get the full points on that. But next would be graphing, because you also have to now solve it by graphing and be able to tell me what your solutions would be. So let's graph that. Let's start with the bottom one, because that's easier to convert to slope-intercept form. Slope-intercept form means I need to isolate what? The y. So let's start with the bottom one, because that's easier. How do I get rid of that x? And whatever you do on one side of the symbol. All right, don't flip the sign when you subtract. Only flip the sign when you multiply or divide a negative on both sides. So one of the things I'm going to graph is this. So what's my y-intercept? All right, so find where the 8 would be. 1, 2, 3, 4, 5, 6, 7, 8. And then table 1, what's my slope? So Harley, you're hearing, what's my slope for this? So your slope is in front of the x, not the x itself, -1. So that means I'm going down 1 to the right 1. Down 1 to the right 1. Elijah G, would this be solid or dashed? Okay, class, can we help them out? Don't tell them the answer, but where do I look at to tell me if it's solid or dashed? The inequality symbol. Does that help a little bit?
Yeah.
Should be solid. So anytime it has that equal to part in it, then it should be a solid line. If it doesn't, if it's just greater than or less than, then do dash. But this one has a equal to part, so just like an equation, make it a solid line. And then let's see, table 3, shaded above or below. All right, and then I can't really do lightly with this, but just picture it as lightly. So that's just the one inequality. We still need to graph the other one, which that one's not too hard to make slope-intercept form. What do I need to do to this one to make it slope-intercept form? Subtract 2x on both sides. So we do one side, do to the other. So now the y is alone. What's my y-intercept for this one? All right, let's see if I can even fit 15 on here. But yeah, that's my y-intercept. 9, 10, 11, 12, 13, 14, 15. And then what is my slope? Table 2. What's my slope when it looks like this? 15 minus 2x. And this is taking longer than it needs to, guys. This is one example, but it's something that you will be doing Friday completely by yourself. So table 2, Mason, Cohen, or John. The question is, what's the slope? No, that's my y-intercept. Try again. -2 is my slope. So that means from the y-intercept, you need to go down 2 because the rise is affected by negatives. And then you still have a run, even if it's not written. The run is 1. So from that, go down 2 to the right 1, down 2 to the right 1. Table 6, will this one be solid or dashed? It would be solid because it has that equal to part of it. So draw your solid line as straight as you can. And then class all at once, will this one be shaded above or below? Below. So lots of shading going on, but the solution is only where exactly? Where where they intersect, where they overlap specifically. So only coordinates that are in this area where the shading would overlap. So let me make it like nice and dark. So only where it's shaded in black is my solution to the system. So when you take your test, I need to very clearly see what is your solution. Either label it with an S, where it overlaps, or point to it and make it really dark so I can tell. Because there might be shading like everywhere else, but only the black is my solution. So then when it asks to give you an answer, for example, a coordinate that falls in there would be, say, like 1, 9. And that would mean you can attend 1 baseball game, 9 soccer games. We said X was baseball games, Y was soccer. Anything in that black area between them would work. So questions, comments, concerns? All right. In period 2, if you want to go back and watch that recording, we did another example that's similar to this, but also just more practice for what you're doing Friday. You have a to-do list. Your points for math lab today are making sure that you get 80% or higher on today's practice. But still, like, I had at least 2 of you not turn in the booklet. So make sure you do that. So that is assessment points in math lab. But then here's other things you can do if you already met on 80% or higher. Yes. Yeah. You could always ask questions as you go, but otherwise I'll check in like last 20-ish minutes. Make sense? Yes, right? When you do that. And that one has you selecting all the pairs of X and Y that are solutions to this system of inequalities. So what does select all mean? John? All that apply. So could it be that just one is correct? It could be. I just like to mention that because some people think it means that you have to pick more than one, or that it has to be like more than one, but it doesn't have to. It could just be one that applies. But let's see. If you're solving this, the only way to solve systems of inequalities is by graphing. So highly suggest you do that, especially when you have all these coordinates to check. And you also have to know how to identify your solution from a graph. So would you guys rather graph this by hand or with Desmos? Okay, I agree, especially if this was like a test where time is limited. So that means type in your inequalities, exactly how they look on the question. The inequality symbols are all right here if you don't know where they are. And then the other one is X minus Y less than 6. So the perk of Desmos is you don't have to make it slope-intercept form. And you can see the graph like this. Now, these values, they give you an X and a Y. They don't write it in coordinate form, but that doesn't mean you can't. Like, just make sure you put the X first. So like if I test out the first coordinate, -5, -15, is that one going to be a solution based on where it is? So yes or no, is this one a solution? So actually no, because it only meets one of the constraints. It only meets the one that's in red. So don't pick that one. Let's try 0, 0 now, see if that's a solution. And is it? So definitely pick that one because it's in the overlapping shaded area. Now try where it's X equals 3, Y equals 0. Is that one a solution? All right, so it's a little bit harder to tell because it's on the line, but it is on a solid line that is touching the overlapping shaded area. So I would say yes, but if you're not sure, you could also plug it in and confirm it algebraically, because if it's a solution, it makes it true. And if it's a solution to a system, it has to make both true. So in that case, if I plug it into the top one, hopefully it lets me write. It wasn't letting me earlier for some reason. Okay, so 0 is what y is. 3 is what x is. So what's -2 times 3, class? -2 times 3, yes? If it lets you, like, you can just start it. If you need another attempt, then that's when you yes. -6. And then +6 is what, class? So is 0 less than or equal to 0? So it meets that first one. Then if you try the second one, x minus y, so 3 minus 0 is 3 less than 6. So then for sure, if you're unsure because of where it is, like on the line, then plug them in and then see. All right, questions on that? Let me try the other ones for -2. All right, now look at where that one is. Is that one going to be a solution? Okay, and why no? Because it's on a dotted line. So it doesn't meet the blue constraint because it's on a dashed line for that one. Therefore, it can't be a solution to the system because it doesn't meet both. Okay, but even that one, I wasn't really sure earlier. I know now because I already had a class today that asked about that one. But if I needed to verify algebraically, I could. Like, I just plug in y they're saying is -2, x they're saying is 4, and then see if it gives you something that's true. So I get -2 less than or equal to -8 plus 6, which is -2. Is this true? Is -2 less than or equal to -2? So then it meets that one. So then when you check the other one, 4 minus the -2, that's the x minus y. That double negative really becomes a positive. It ends up being 6 less than 6. Is that true? Is 6 less than 6? So then it doesn't meet that one. That's why it's not a solution. And then there's one more to check. 10, 0. All right, 10, 0 is the last one. Let's see where that one's at. Is that a solution? Okay, definitely not. So just these two then for that one. All right, questions on any other parts of this one or like the study guides or anything else? All right, the puzzle piece one. Okay, so let's pull that one up. And what number? Okay. It's if you go to the main page of Schoology, it's on the materials page. It should be toward the top. It's not in a folder because I want you to be able to find it really easily. And you said number 3, right, Cohen? Okay. So number 3 on the study guide should look like this. Correct me if it's not that one. But we have this inequality and it says which value of x is a solution to the inequality. So you have two options. You could solve the inequality and then see which one could meet that constraint. Or you could plug in each answer option and then see which one makes it true. It's up to you. But let's just show you how to solve it, because not all the time will you have multiple choice. So this one, I know students don't really like as much because there's fractions involved. But I told you how to make anything no longer a fraction. What do you have to do? Multiply it by the denominator. And in this case, I have two fractions, two different denominators. You could like try to kill two birds with one stone and multiply it by something that will give you both fractions canceled out. Or you might just have to do it one at a time. It's up to you. What do 2 and 4? Maybe let me not phrase it that way. If it were me trying to cancel it out, the denominator of both fractions at one time, then I'd be best multiplying it by 4. The entire thing. Because then I get 4x over 2, which simplifies. I'll simplify it in the next step. 4 times 1 is 4. And 4x over 4, which again will simplify. So what's 4 divided by 2? So then that just becomes 2x. And no, I did not need to flip the sign because I multiplied by a positive on both sides. So you can leave it alone. And then over here, what does the 4 over 4 simplify to? So then I just get 4 plus x on this side. And now it's a lot easier to solve now that it's no longer a fraction. Keep that in mind when you do that in your test. But anyway, so we made it easier to solve. Now you probably want to move the variables to one side. Doesn't matter which one you move. I suggest moving the smaller one. So how do I cancel out that x? Subtract it, whatever you do on one side of the symbol. What's 2x minus x class? No. If I have 2 x's and I take away one of them, I have just 1 x. So then that gets the x alone. I don't need to flip the sign at all because all I did was subtract. So then I get x greater than or equal to 4. But that's not what this says. It says which value of x would be a solution. So what value of x would make this statement true? So which one of these is greater or equal to 4? X equals 6. Because if I plug in all the others, 3 is not greater than or equal to 4, -3 is not greater than or equal to 4, but 6 is. And then -6 is not. Does that make sense? Okay. Questions on anything else? On the study guide? All right. So number 4 on the study guide. So Yvette has up to $2,000 to invest, and she chose to put her money into telecommunications and pharmaceuticals. The telecommunications investment is to be no more than 4 times the pharmaceuticals investment. Select all the equations or inequalities that could describe the situation. Let X represent the amount in dollars invested in telecommunications and Y represent the amount in dollars invested in pharmaceuticals. Feel free to read that a few times so you understand what's going on. But it's saying select all that could represent the situation. So instead of going like line by line telling you why it's not that one or why it could be that one, let's just go through from the beginning, and anywhere that there's a constraint, represent it. So for example, Yvette has up to $2,000 to invest. So 2,000 would be a total, right? Or a constraint. If she has up to 2,000 to invest, can she invest more than 2,000? So then flip around the sign. She could invest less than 2,000. Could she invest in exactly 2,000? Yeah, if it's up to 2,000, it could be the 2,000. So then even that alone, you could eliminate some of these. like this one. By the way, it told you X is telecommunications investments and Y is pharmaceutical investments. So yeah, you don't want what you invest to be equal to 2,000 because it can also be less than or equal to. It's not just less than, and it's definitely not greater than or equal to. So that gets you at least one of the answers just from that. Then you keep reading until you see another constraint. So the telecommunications investment is to be no more than 4 times the pharmaceuticals investment. So 4 times the pharmaceuticals investment, which variable is the pharmaceuticals investment? So no more than 4 times Y. If it can be no more than, should I use that symbol? So then flip it around. And then can she invest exactly that much if it's no more than? And then have a little line there. So then it should definitely not have it be 4 times X because that would be times the telecommunications, which is not what it said. Over here, it looks like it could be right, but it has a symbol going the wrong way. So don't pick that one. This one would make sense because you're comparing it to the telecommunications. So pick that one. And then don't pick this one because it's not multiplying by the pharmaceuticals like it should. So then it's just those 2. Questions on that one? Okay. May have time for one more depending on how long it is. If you have more questions, you can always email. I do have a tutoring tomorrow. It'd be great because it's before the test.